Hi everyone, this is where we left off in our notes today in class, and so we were talking about right triangles. And so remember, a right triangle is just a triangle that has one right angle, and we have some special names for the sides. The side across from the right angle is called the hypotenuse. It is also the longest side of the triangle. And the remaining sides are named by their relationship to the given angle, which is sometimes called the reference angle. Okay. And so the remaining sides are either adjacent, meaning next to or beside the given angle, or opposite, meaning the side is across from the given angle, or the reference angle. Okay, so let's look at these two right triangles, just so you get an idea. I would always start by labeling the hypotenuse. So look for the side across from the right angle. So in this triangle, that would be side AB. It is opposite the right angle. Now, the other two sides we're going to label opposite or adjacent, but that's in relation to the given angle, which right now is represented by theta. This is a Greek letter. And you'll find that when we continue with trigonometry, we tend to use some Greek letters for symbols. So this is called theta, and often we use it to represent an acute angle in the right triangle. Okay, so in relation to angle A, which is represented by theta, that would be the reference angle or the given angle. Side CB is opposite that angle. And side AC is adjacent or next to that angle. Okay? Now, let's look at this other triangle. So if you notice, the reference angle or the given angle is now angle B. Now that doesn't change the hypotenuse, because remember, the hypotenuse is always opposite the right angle. But that does change the opposite and adjacent side. So now side AC is opposite angle B, and side CB is adjacent to angle B. Okay? So your opposite and adjacent are all in relation to the given angle. And we're talking about the acute angles in the triangle. Okay? All right, so another thing that may come up is Pythagorean theorem, so I wanted to review that. So remember, this applies to a right triangle, and it basically has to do with the side lengths of a right triangle. And I know you remember it. It's a squared plus b squared equals c squared. The important thing is that c is always the hypotenuse. Okay. A and b are the legs. And it's okay if you switch around A and B, but it's very important that you always plug in the hypotenuse for C. Okay, so there are really two different scenarios that could happen when you're using Pythagorean theorem. So if we look at number one, here we're given the legs and we're solving for the hypotenuse. So if we start by plugging in A and B, we're going to get 4 squared plus 6 squared equals c squared. Okay, so then the next thing we would do is evaluate our exponents. So 4 squared is 16. 6 squared is 36. And that equals c squared. Okay, and then we will add. So if we add 16 plus 36, we get 52 equals c squared. And then to undo c squared, we would square root each side. And in this case, we are going to use the positive root because we are finding the length of a side of a triangle. So in that case, the negative root really wouldn't make sense. Okay. All right, so basically we get c equals square root of 52. Now, you could keep that in your calculator, but you would have to round it. So in trying to keep an exact answer, we would rather just simplify the radical. And so simplifying the radical is where you look for a perfect square factor of 52. And so your perfect squares are like 1, 4, 9, 16, 25, 36, 49, 81, 100. Okay, so anyway, 52 is also equal to 4 times 13. And 4 is a perfect square. So then what we can do, there is a property dealing with radicals where if you are finding the square root of a product, you can find the product of the square root. So basically you can split it up like this. And then we could just find the square root of 4, which is 2. Okay, so this is basically simplified form. And we get 2 square root 13. Okay, but that would be an exact answer, which is what we prefer. Okay, your second scenario is where, notice we're given A, which is a leg, and we're given C, which is the hypotenuse, and we're solving for B this time. But let's start by plugging in. So we would start with 5 squared plus B squared equals 12 squared. And again, then we're going to evaluate our exponents. So we get 25 plus B squared equals 144. So this time, since we're solving for B, we would actually want to subtract 25 on each side. All right, so we would end up with 119. And then we would square root each side. And again, we would be taking the positive root and I don't believe we can actually simplify. Okay, so we're going to stop there. But anyway, here notice when we were solving for a leg, we had to subtract and then square root both sides. All right, moving on. Finally, we're going to get into our trig functions. This is where we've been heading. So you probably remember these from geometry. The first 3 trig functions are sine, which we abbreviate with SIN, okay? The full word is SINE, okay? So when you see this abbreviation, it's pronounced sine, not sin, okay? Cosine, which we abbreviate with COS, but again, the full word is COSINE, cosine. And then the third one is tangent, which we abbreviate with TAN, but again, the full word is TANGENT, tangent. And these are ratios of the sides of right triangles. So sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You can use this to remember SOHCAHTOA. So the S stands for sine, the O is opposite, H is hypotenuse. So you can remember sine is opposite over hypotenuse. And then C is for cosine, A is adjacent, H is hypotenuse. So cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay, it's just an easy way to remember. Now, there are actually 3 more trig functions, and these are reciprocal trig functions. So basically, if you just take the first 3 and flip them, you get the reciprocal trig functions, okay? So the reciprocal of sine, remember sine is opposite over hypotenuse. So its reciprocal is called cosecant. So it would be hypotenuse over opposite. And the full word for that is cosecant, cosecant. We just abbreviate it with CSC. All right, the reciprocal of cosine is secant. Again, here's your full word. Again, we just abbreviate it SEC. And again, so if we take cosine, which is adjacent over hypotenuse, and we flip it, we get secant, which is hypotenuse over adjacent. And then the reciprocal of tangent is cotangent. Here's your full word, cotangent. So again, tangent is opposite over adjacent. So if we flip it, we get adjacent over opposite. All right. Now, here's an easy way to remember these. The S and the C always go together for South Carolina. So just remember that. Here's your S, here's your C. And then tangent and cotangent, they just tend to go together by their names. So, all right, so let's look at an example. We want to find the values of the 6 trig functions of theta for the right triangle. So the first thing you want to do is label your sides, okay? So start with the hypotenuse. So 17 is the hypotenuse. And then the other 2 sides are in relation to theta. So 8 would be opposite, and 15 would be adjacent. Okay, now when you're writing your trig ratios always have an angle with them. So basically, we would be finding sine of theta, okay? So we're saying that sine of theta, the ratio of those sides, sine is opposite over hypotenuse. So that would be 8 over 17. And we're just going to leave it in exact form instead of rounding. All right, cosine of theta would equal, now cosine is adjacent over hypotenuse, so that would be 15 over 17. All right, third one is tangent of theta. Tangent is opposite over adjacent, so that would be 8 over 15. So you can see once you label the sides of the right triangle, these are pretty easy. All right, now the remaining 3 are reciprocals of the first 3. So the reciprocal of sine is cosecant theta. So all you have to do is flip it. It'd be 17 over 8. All right, the reciprocal of cosine is secant theta. So again, we're just flipping it. And the reciprocal of tangent theta is cotangent theta. And so again, we're just going to flip it. And now we have the 6 trig ratios for theta. All right, now sometimes what we can do, and this basically is how we can use the trig functions to solve problems. The trig functions are helpful when you're given an angle and a side. So like if you look at this right triangle, we couldn't use Pythagorean theorem because that only works if we know 2 sides and we're solving for the 3rd side. So here we would need to use a trig ratio. Again though, I would start by labeling the sides of the right triangle. That's the first thing you always want to do. All right, so y is the hypotenuse. X is adjacent to the 37-degree angle. And 9.7 is opposite the 30-degree angle. Okay, so let's solve for x first, okay? So if we're solving for x, we're going to have to use adjacent and opposite. So refer to your SOHCAHTOA. The trig ratio that compares opposite and adjacent is tangent, okay? So we could set this up as tangent of 37 degrees equals opposite, which is 9.7, over adjacent, which is x. And then we basically are going to solve for x. Now, To solve for x here, you can look at this like a proportion, like if I put a 1 under tangent of 37 degrees, and you could cross multiply. So if we cross multiply, we're going to get tangent of 37 degrees times x equals 9.7. And then to undo the multiplication, we would just divide by tangent of 37 degrees. Now, at this point, you would actually use your calculator, and you've probably used the sine, cosine, and tangent keys before. You would want to make sure your calculator is in degree mode, and I'll show you this in class tomorrow. But for right now, I'm just going to get our final answer. 9.7 divided by tangent of 37 degrees is approximately 12.9. Okay. Now, in order to solve for y, at this point you actually have a couple options. Like, since you know two sides now, you could use Pythagorean theorem to find the third side. But let's practice with the trig ratios again. So if we want to solve for y, this time we're going to use hypotenuse and opposite, or opposite and hypotenuse. So again, if you think back to your SOHCAHTOA, opposite and hypotenuse is represented by sine. So we could set this up as sine of 37 degrees equals opposite, which is 9.7, over hypotenuse. And then you may have noticed when we solved for x up here that basically we ended up just switching x and tangent of 37. So yeah, here to solve for y, we would just end up with 9.7 divided by sine of 37 degrees. And again, I'm just going to put that in the calculator. And we get approximately 16.1. Okay, so again, that's just showing you how we can use these trig ratios to solve problems related to right triangles. Okay, now in this example, it says let theta be an acute angle such that sine of theta equals 5 over 6. Evaluate the other 5 trig functions of theta. So this is where you're using one trig ratio to find the others. So what you want to do is start by drawing a right triangle. And then pick one of the acute angles to be theta. It really doesn't matter. I'm just going to pick this one. All right. Then, again, you want to label your sides. So this would be the hypotenuse. This side is opposite theta. This side is adjacent to theta. Okay, now remember, sine of theta is always opposite over hypotenuse. So that gives us 2 side lengths of the right triangle. So this side is 5, and the hypotenuse is 6. Okay, we're going to have to find the third side. So we need to use Pythagorean theorem. All right, so we could set it up as a squared plus 5 squared equals 6 squared. All right, and then 5 squared is 25. 6 squared is 36. We're going to subtract 25. And we're going to get a squared equals 11. And then we're going to square root each side. And again, we're going to take the positive root. And we cannot simplify that. So we get square root of 11. All right, then we're going to write the rest of the trig ratios. So cosine of theta, remember, is adjacent over hypotenuse. So that would be square root of 11 over 6. All right, tangent theta is opposite over adjacent. So that's 5 over square root of 11. All right, so then we have to find our reciprocal function. So cosecant theta, remember, is the reciprocal of sine. So that's hypotenuse, which is 6, over opposite, which is 5. All right, secant theta, which is the reciprocal of cosine, so we can just flip cosine, would be 6 over square root of 11. And then cotangent theta is the reciprocal of tangent, and so we can just flip tangent and get square root of 11 over 5. Okay. Moving on. All right, so getting the answers with the calculator, we'll go through that in class tomorrow when everybody has a calculator. So let's move on. Okay, the last thing we need to talk about in tonight's video is how to use the trig functions to find an angle. And so to do that, we actually have to use the inverse trig function, okay? All right, so for instance, in this first triangle, we want to find the measure of angle A. So again, start by labeling your sides. 6 is the hypotenuse, 4 is opposite of angle A. Refer to your SOHCAHTOA. If we're comparing opposite and hypotenuse, we would want to use sine. All right, so we would set it up like this. Sine of angle A equals opposite, which is 4, over hypotenuse, which is 6. Okay, now we're going to use our inverse trig function. Remember, your inverse function switches your input and your output. So here's how we write it. Inverse sine of 4 over 6 equals A. Notice that it literally just switches your input and your output. Now, if you look at your calculator, your inverse trig functions are right above the other trig functions, the sine, cosine, and tangent. Okay, so all you have to do is hit the second key and then sine, and then put 4 divided by 6, enter, and angle A is approximately 41.8 degrees. Okay, let's look at a couple more, and then we'll be finished. So over here, again, start by labeling your sides. The 2.5 is opposite, the 5 is adjacent. So refer to your SOHCAHTOA. Tangent compares opposite and adjacent. So we would set it up. Tangent of angle A equals opposite, which is 2.5, over adjacent, which is 5. And then to solve for the angle, we're going to use our inverse trig function, which will just switch our input and our output. And then we're going to go to the calculator. And angle A is approximately 26.6 degrees. Okay, last one. Start by labeling your sides. So this one, the 4.5 is adjacent, the 3.2 is opposite. So again, we would use tangent. Tangent of angle A equals opposite, which is 3.2, over adjacent, which is 4.5. Then use your inverse trig function, which again switches your input and your output. And then go to your calculator. And angle A is approximately 35.4 degrees. Whoop. Okay. So that concludes the video. We're going to practice this some more in class. See you tomorrow.